Hello, everyone, and welcome back to this Kobo antibiogram. Hopefully, this is the last video. Hopefully, we'll finish the analysis today. So, yesterday, the last video that is, I had shown you how to download the data that you have already entered into the Kobo app, how to download it as an Excel file. And so now I've downloaded my Excel file. I've relabeled it as for video, and this is going to be the data we are going to use in order to create the antibiogram. So I'll go ahead and open it. For this video, while we open the Excel file, also I want to introduce to you this open source statistical software that I'm going to be using for this analysis. It's called Jamovi. Jamovi is an open source software. So you might have used SPSS earlier. So that is a paid software. So I just wanted to find something that's open source that is, open for using and downloading, and something that's simple also. So I've come across Jamovi and I'm planning to use this for the video. So go ahead and download the Jamovi software, and so this is how the homepage of jamovi.org looks like. And go ahead and download the software, and whichever system you're using. And after having downloaded it and having installed it, we can head over to using it. So I open this software, and I'll be showing how to use it. And this is how the software looks like. It's very simple. So the left hand side, where the boxes are there, is where your data is going to be, and on the right hand side is where the results are going to be seen. It might be tables, it might be bar graphs, whatever. So here we're just going to create tables that will enable us to make the antibiogram. We'll go ahead and import the come on, man. We'll go ahead and import our Excel sheet which we have downloaded. So one of the main reasons why I chose to go with Jamovi, even when there are other open source um, statistical software, is Jamovi directly can work with Excel. That's one of the problems that other open source softwares may have. You'll need to convert it into another data sheet format and then use it. So so you can go ahead and import the Excel sheet which you have downloaded from Kobo. So I've already used mine here, so I'll go ahead and use the recent. As you can see, all the data is now seen on the left hand side. I'm able to scroll through it completely, and the first row of the Excel sheet has been taken as the heading for each of the columns. So what I'm going to do here is we're going to get some data. So the aim is to know the sensitivities of the specific bacteria for the antibiotics we've checked for based on the source. So we need the blood culture reports to be separate, the urine culture reports to be separate, and sputum cultures to be separate, and so on. Plus, we need to know the sensitivity organism wise from the source, the respective sources. So after mixing and matching and trying all the methods possible, this is what I've learned. So I'll just teach you what I've learned. So go ahead and click the exploration option, which is the first option under analysis, and select descriptives. So we're going to do some basic statistical work. So I'll just show you some examples. For now, under the heading of variables, we're going to select the antibiotics for which we are checking, or for which we are, checking the susceptibility towards. I am going to just select a few antibiotics. You can select all of the antibiotics that you have entered for. I'm going to take amikacin, say cefazolin, and say gentamicin. Anything meropenem. Okay, I'll take meropenem. Basically, the idea is to put all of the antibiotics under the variables column, because you're going to see if it's going to be sensitive or resistant. And we are going to split the sensitivities of these antibiotics by the source and the name of the organism. So that's what's going to come under the split by into this box, which is headed as split by. So we're going to say the specimen source will come there, and the organism isolated is going to come there. So I'm going to go ahead and click this frequency tables options. So as you can see, as soon as you clicked all of these data, the tables start appearing on the right hand side. So the results have loaded. Just ignore the first heading that's under descriptors and head on to the frequency tables. That's what will be very useful for us. Yeah. So once we've reached the frequencies, you can see that the tables have been made antibiotic wise. So first it shows the frequency of amikacin. The beauty here is the software has already split up the the microbial organisms based on the source of the specimen, whether it's blood or pus or sputum or others. So that's the beauty. And then on the rows we have the various names of the organisms that have been isolated. So let's just take amikacin for example. You can see that around 24 organisms of E. coli that have been isolated from the urine are sensitive to amikacin, whereas only 4 of them are resistant. Okay, so this is just for amikacin. Likewise, you have the data for meropenem, and also you have the data for cefazolin, because these were the three antibiotics that we selected under the variables column. Okay, under the heading of variables. So this is in fact a very large amount of work in order to consolidate all the data that we've collected. Up to this itself is a big deal. Trust me, because I tried to do it on Excel and it was really complicated. Probably I didn't know how to do it properly. But the problem is, this itself will not be enough data to put up as an antibiogram, because if you want to make an antibiogram, as we saw in the initial video, the heading has to be the microorganism's name. Okay, so the microorganism name has to come in the top, and then you have to have a list of the antibiotics on one side, and then you have to know how much percent of it is sensitive and how much percent of it is resistant. So that's how the final picture has to be. So go ahead to the first video if you want to know how the antibiogram is supposed to look like. So, but this is a significant part of making that. Probably the penultimate step. Yeah, definitely this is the penultimate step. So what I'm going to do here is, we have all the results here. I'm going to copy. So I gave a right click and selected all and gave copy. I'm going to open a Word document. So now we've copied all the data that we had on Jamovi software onto the Word document. You can see that clearly there are tables made, and mainly under this frequency table, this is where the data that we want lies. So we'll use these data and then finally enter them into an Excel sheet. So I'll just show you an example of how the final antibiogram is supposed to look like. I haven't made it, but I'll just show you an example of how it's supposed to look like. So I'll just go ahead and open a new Excel sheet. So say you're going to make the antibiogram for an E. coli. So it's going to be E. coli, and you need to enter the source. So it has to be whether it's from a bloodstream infection or from a urine source. And so once this will be the heading, and then go ahead and enter some antibiotics. I'm going to enter amikacin, gentamicin, piptaz, meropenem, and meropenem. Yeah. So and you can enter more antibiotics. Many of the other ones you'll be checking for, and then here. Okay, so here we are going to enter sensitive. How many samples? Mainly, I have to enter the percentage there. So sensitive and resistant. So okay, I'll just give amikacin, meropenem, and cefazolin because that's what I've used for this example. Okay, so we're going to go to the blood. Oh, we'll use the urine infection that seems to have more number of samples there. So okay. So in my sample, the under amikacin, yeah, yeah. So frequencies of amikacin under urine, we see E. coli. There's 4 resistant and 24 sensitive. So let's go ahead and enter that 4 resistant and 24 sensitive. That's for amikacin. Resistant, yeah. And then when we go move ahead to cefazolin, the number of resistant E. coli are 22, whereas only 6 are sensitive. So 22 and 6. 22 is resistant, 6 are sensitive. Let's go over to meropenem, and here we see that only 5 are resistant, whereas 23 are sensitive. 5 are resistant and 23 are sensitive. So we'll go ahead. We know that N is both of these things added together, which is N is equal to 28. So N equals 28. And so these are the absolute values. What will be more useful is if we have a percentage. So just a simple way to calculate the percentage, of course, I'm just going to enter a formula. So which is equal to this divided by this plus this, close the bracket, into 100. Okay, that didn't work out well. Okay, I get it. I think we can close the bracket here. Yeah, that's better. So that's going to be the sensitive part and the resistant. The resistant part is going to be equal to this divided by this plus this into 100. Yep. So that's what the beauty is. If you have some 10 antibiotics here, you can just drag this and the formula will just get automatically updated according to that line. So hence making the work easier. So, so finally, the antibiogram will look something like the sensitives and resistant, the total number, so the total number, the n value, and the antibiotics that you're checking for. And hopefully, yeah, the sensitive you can put it as green, and you can put the resistant ones as red in order to make it. Yeah, so this is how your antibiogram, final antibiogram, will sort of look like. Yeah.